In this example of a developmental network, I will show how the characters of Super Mario interact to determine the outcome of whether or not Princess Peach is freed from Bowser's castle. In our wild-type genotype, we have Luigi activating the transcription of a fireball, which then represses or blocks the transcription of Bowser, who is repressing the transcription of Mario, which activates the transcription of Peach, allowing her to be freed from the castle. How does this pathway work? Well, one way that regulatory factors can affect the level of transcription is if we have something called a repressor protein. If the repressor protein binds to our line of DNA in the same place that RNA polymerase is supposed to come in and bind, and it can no longer do so, then RNA polymerase cannot continue our transcription, and nothing after the last gene will be transcribed. On the other hand, if there is an area on the DNA sequence where RNA polymerase cannot quite bind on its own, something called an activator protein can come in and bind to the RNA polymerase, which then allows transcription to occur. What would happen if we had a mutant genotype where we were missing a single gene in our line of DNA? In this case, Luigi would not be activating anything, which means that Bowser has nothing blocking him, allowing him to block Mario, meaning that he is not able to transcribe Princess Peach or free her from the castle. What if we had a double mutant missing 2 genes? In this case, we do not have Luigi, which means that our fireball is not transcribed. We also don't have Bowser, so even if we had the fireball, nothing would be blocked, which means that Mario is free to transcribe Princess Peach and she is freed from the castle. This simple example shows that the interaction of all transcription factors and regulatory proteins are important in the level of transcription and the outcome of our DNA sequence and the phenotypes that it provides us.